Hey everyone, Noah here, and today we are talking grid models in TMC. Now, what is a grid model? A grid model is a digital representation of the Earth's surface. A grid model is a digital terrain model, also known as a DTM file. Your grid model is your survey surface, your pre-dredge surface, and your as-built surface all in one. This is the surface that your machine will update with its bucket, cutter head, multi-beam, etc. A grid model is typically made from point cloud data or ASCII data, like an XYZ file or a CSV file that you get from processed bathymetric survey data. A grid model consists of a bunch of cells. The cells are a user configurable size. Typically, we run about 1 foot cell size. So when this file is created, all the points in a 1 by 1 square will be averaged out, and it will assign that cell the average data. And then it will stitch it all together and give you a nice clean surface like you see behind me here. So follow along, guys. Today we'll be going through gathering data, importing data, creating the surface, loading into the machine from within acquisition, as well as some editing and some other cool things we can do with grid models. So thanks for tuning in, and I hope you enjoy. Let's go. All right, guys, let's start off by gathering our data. So what we are looking for is an XYZ or CSV file with all of the processed bathymetric survey data in it. This is going to be a point file, right? So I can pull up my file here. Let's have a look at it. Both of these are the same. One is a CSV, one's an XYZ. We'll open up the XYZ. Take a look at that. Here we go. Just a bunch of points separated with commas. All right, let's get it loaded in and make the grid model. From Control Center here, we'll find the grid model folder. And what we can do here is right click on it and make a new file. We'll go ahead and call that grid model 2. We'll save that. We can save it as a generic model type for use in machine control applications. Save that, and it's going to come up with some options here. It's going to ask you what kind of data do you want the grid model cells to store. Typically, in machine control applications, the average is all you're going to need, and we'll keep it at that 1 foot cell size. Go ahead and hit OK here, and it will launch the grid model editor module. Over here on the left side, we have the option to select our data. We either can take it from a PDF log file set, which would be if you were processing your multi-beam data in PDF 2000, you could pull in that PDF file. We don't have that today, so we're going to go with other data formats and click on data selection. Here we have a bunch of other options besides XYZ data. My preference is this ASCII data here for XYZ and CSV, and that's what we're going to do today. Go ahead and hit add, and then navigate in your file explorer here to your data file. We'll grab that XYZ, we'll bring that in, and we'll go ahead here and hit next. We have a couple more options here. A Z scale factor, you're not going to touch that. The coordinate type is grid because our points are XYZ, not lat long height. We'll go ahead and run our ASCII import wizard to make sure we are going to import this data correctly. What you can do here now is you can use an import configuration if you already have one saved. What we're going to do is create that import configuration and save it as XYZ files. We'll hit next. and we have a delimited file because we have a bunch of commas separating our data, right? So next, we'll select our delimiter up here. We have a comma, so that's right. If you have the wrong delimiter, your data will definitely not look correct in the preview below. If you have header information and need to skip some lines, you can go ahead and check this box here and then tell it how many lines you want to skip. And lovely TMC wants an integer, so be sure to highlight and then type your number in. We need to go one more here because we have 2 lines of data. We'll take both of them out. And now we can go down to our preview window here. And these 3 dots at the column headers, go ahead and right click on each one and then tell the column what data it is. So this data is easting northern height. So we'll go ahead and assign those in that order. Everything is looking good now, and we can hit finish and go ahead and finish again. Now over here, we can import the data. Note here, a clipping polygon, we'll talk about that in a bit, but if there is a clipping polygon selected here, you're only going to get data imported inside that polygon. We'll leave it at none and hit import. And here we go. Here's our data. It's pretty dense data, so it comes through looking like a surface already. If your data is not as dense, you will see a bunch of points here. Points are not usable to us because we have to create the surface. And to create that surface, we need to interpolate. So over on our left side here, we have the interpolate tab. And there's some options here for how to interpolate. For the purpose of today, we're just going to interpolate circular here. You set the max gap of distance between your points. You kind of just look at how dense your data is and make an educated guess here. I know my data is dense, so 5 feet is going to be more than plenty. We'll go ahead and interpolate circular. And interpolating circular goes pretty quick. Now, if you wanted to interpolate triangularly or directionally or whatnot, you can do that. You just need some more data. Like for triangular, you need to have a clipping polygon, and directional, you need to have run lines. For the most part, circular is going to do the job just fine. So now we have a surface here, and it looks kind of blah. So we'll go ahead and make a color table to give this surface some definition. In the Operations tab, we'll hit the Operation dropdown and generate a color table. Here we will pick what color table we want to adjust, and we will just use the grid model one that we created here. And we will use the Z average type, no clipping polygon, and we'll do hues for the colors. Gray is the black and white scale, rust is red and yellow, hues is the full rainbow. Go ahead and hit generate, and we got some definition here now. Now we can look in the top left corner here, we can toggle the 3D view and even give it a more detailed inspection. But that's it, guys. That's all you have to do to get that grid model created. From this point, we are able to do a number of things. We can edit the file, we can delete data, we can add data, we can extract profiles, create contours, do volume calculations with these grid models. There's a lot. But right now, we're going to close this out and get it loaded into TMC acquisition. So that way, the machine can update the surface and you can get on to dredging. Now we can go ahead and hit that play button up here to launch acquisition. And there's our machine. Let's go ahead and load this grid model in here so we can use the machine to update the surface. So in the dredge construction, dredge surface control bar, if you have it up, in the survey model dropdown, you can go ahead and select that grid model 2 that we created. There you go. And now it is loaded in. and the machine can update the surface. Granted, our logging settings are correct. Another way to load this grid model, if you did not have the dredge surface control bar, would be to navigate to the logging button up here and into logging settings. Do note that if data logging is enabled, that logging settings are not able to be selected. So you have to uncheck or disable data logging and then go into your logging settings. And here we can click on the grid model format, and it gives us that same kind of drop down to select that model, grid model 2. And it is always good to verify that you have a data item from the machine added to the logging data section here. Go ahead and hit OK. Load that in here, and we will toggle back on that data logging. If we pull our simulator over here, we'll run our excavator, and we can take a scoop out of that material. So that grid model is updated in real time based on the bucket passing through the model. Now your grid model is automatically saved right away. So when you are done with acquisition for today, you don't have to worry about hitting the save button or anything. All you gotta do is close out acquisition and it is saved. And we can verify that by going back into our grid model editor, double clicking over here on our grid model 2. And there, if we zoom in, you can see that bite that we took out with the excavator just now. All right, guys, now let's see what other features are available in that grid model editor. So go over to your grid model file here and double click on it to launch the grid model editor. And what we will do first is some basic editing. So if we click on the edit tab on the left side here, we have a few options. We can delete, interpolate, delete and interpolate, or we can update just a single cell. We'll start out by deleting. When we check that box here, you'll see we have a crosshair on the screen, and we can lasso any part of that grid model to delete it. There is an undo button in the top left here if you decide you did something wrong. Alternatively to lassoing, you can left click to create corners for a nice straight box cut, and then hit the right mouse button to complete and delete. We can also do this editing in the 3D view, which typically is gonna be easier to do. So we'll go to 3D and we will select our delete button, and let's say we don't like this little hump over here. We'll lasso that and take it out of the mix. Next up is interpolate. What you can do is you can interpolate circularly in a specific area. So say we wanted to interpolate the spot we just deleted, but we don't want to interpolate anywhere else. We can just lasso that area here and interpolate across it to fill that data back in. Alternatively, we can delete and interpolate, so we can put both those two steps into one. If we want to get rid of this hump here, we'll lasso the hump, and it will delete and interpolate across in one step. Lastly, we can update a single cell. So if we're in the 3D view here, we will get a nice top-down view, and we'll go ahead and click on a cell, and we can set the Z average value to 5 feet, any elevation you want really, and you can see that it put a spike in there. Now, single cell updating is easier in the plan view, I believe, to get more precise control over the cell that you'd like to update. So we'll go ahead and do a couple here, and then we can move right into the spike filter settings. So now that we have a few spikes in here, we can use the automated filter tool in the grid model editor here, up filter tab in the top left, and we can find these spikes and get rid of them. So we'll go ahead and look over here. We can select any clipping polygons that we want to work in. We don't have any right now, so we'll leave that unchecked. I like to use the preview options here, red on green, to give a more distinct display of the spikes. Now we have a couple filter options here. Typically the defaults are good, the 5x5 and 0.8 threshold, but depending on how aggressive your terrain is or how flat your terrain is, you can play with those settings to get rid of the spikes you need to get rid of. And then what we'll do is, within the entire model, we will find spikes. And it will highlight them red for us. And if we hit the remove spikes option, it will take them away. And you can see here, I have 4 spikes that I added, but it did find this area here as a spike as well, but we don't want to get rid of that. So one thing we can do is we can, instead of doing the entire model, we can select an area and lasso around. And now we only look for spikes in that area. And we'll go ahead and remove them. And there we go. That is removing spikes. Next, we will move on to a volume calculation. So in the operations tab up here in this dropdown, there is compute volumes. And what this does here is it gives us an option to compute volumes against a reference surface. In this case, we are going to not use any clipping polygons, and we are going to select a 3D model that we created earlier for the reference surface to see how much material we have to take away on this job. So we'll check the box for model in this reference box here and choose a 3D model and design 2. And just because we have it over here doesn't mean that it's going to show up in our view area. Let's say we want to see that and make sure everything looks correct. We'll go in our view and layer control with the 3 squares here and add a layer for a 3D design model. And then we can select our design 2, and we have a black background here and it defaults to a black model. Black on black isn't going to work, so we'll change it to red. And there we go. There is our 3D design model. Now we can run this report and see how much material we need to remove. So we'll go ahead and we're just going to leave these settings at defaults for now, but you can definitely play with these more to get a better report. So we'll go ahead here and drag that PDF over when it comes up, and here is all of our information. We have to remove 1,129 yards of material. Gives a couple pictures there. We'll close that out. Our next topic, we will do contours. So we'll take away that 3D design model layer to get it out of the mix here and close our view and layer control. Now we'll come over to our contour tab and we will create a new contour definition. So we'll call this definition 1, and we can generate contours in a few different ways here. We'll go from a range right now. We'll say our highest level is 0 and our lowest level is -12. And we want to see a contour every 1 foot. So we'll go ahead and hit OK. And we have a bunch of options over here that I'm not going to go through right now. But with that definition in there, we can create the contour DXF. and we will, out of good practice, put that in our project folder. So grid model 2 definition 1, we'll leave that name there, hit save, and boom, we have our contour file. Next up, let's go through exporting. If we want to export this grid model data after the machine gets done updating or whatever it may be, and we want to put it back into that XYZ or CSV format, we can go to the ASCII export tab. And we can just export the average. We don't care about hit count. That is not relevant in our situation here. We'll go ahead and export to ASCII. And we'll put that in our project folder as well. We'll call this XYZ export. And by default, it's going to try to save to a .asc file. We have the built-in option of CSV, or you can go all files and add your own file extension. We'll just do it as a CSV file for now. And save. Now, if we navigate to our TMC project here, we can open up that CSV file that we just exported, and there it is. Now let's take a look at the update function in the grid model editor. We can go ahead and we can take multiple grid models and combine them together. We can use one grid model to update certain areas of another grid model, or we can use 3D or tin models to update the grid model. What we're going to do here to demonstrate is go to the Edit tab, and we'll delete a section out of the middle here. And now we can go back to Update, and we can combine another grid model with this one. And what we'll use is a copy of this grid model I had made beforehand to replace that big, large section here. And we'll hit Update, and there it goes. Alternatively, we can update with a 3D model. So what we'll do is use our design 2. We'll show this design in here so you have a visual reference of what we're going to update it with. So we'll go View and Layer Control and add our 3D model, Design 2, and change the color again here. And now if we update with the 3D model, we will see that it took out all of that material for us. Lots of use cases for this, guys. I'm just going through to show you the capabilities of what the grid model editor can do. And lastly, what we'll go over today is extracting profiles. So to extract profiles from a grid model, you need a run line file. We made this a little bit earlier. We'll go ahead and View and Layer Control and add that run line layer so you guys can see what I'm talking about. So here are our run lines. It's a 25-foot spacing from each other. What we're going to end up with are extracted profiles on this grid model every 25 feet on the lines that you see here. So we'll go ahead and go to Operation in the drop down and hit Extract Profiles. And we'll use run line, 25-foot run lines, and we will use all 5 run lines here. There are some additional settings here. If you had a more complex run line file, you could kind of use to filter, but we're just going to go ahead and extract these profiles to show you what we can do here. So if we hit extract, we will just put these on multiple displays for now and hit OK. And now we can see a profile. It took up the entire screen, so we'll go up to Window here and tile all of the windows that we have. And now you can see at each one of these lines, we have a profile of the grid model. With these profile windows open, we can also add a layer for a 3D design model. If we go into view and layer control of one of these displays, we can hit the plus button to add a 3D model runline profile layer. Hit OK, and we will select design 2, and you can see design model overlays on the same screen with the grid model. Well, guys, that is it for today's video. I hope you enjoyed. And as always, TMC is a very powerful software tool, and there are a lot of different ways to do the same thing. So drop a comment below, let me know how you do it, what your thoughts are on this video, and what you want to see in the future. Thanks and have fun.